Welcome to Keyloggers across the operating systems. I will be your host, Dan Borges. Professionally, I have done both red teaming and blue teaming in the past. Um, and you'll see I've used a lot of these techniques, both in my offensive operations and detecting them as a blue teamer. Some other things I do is I'm also the CPTC director. This is the Collegiate Penetration Testing Competition. In this competition, we have a bunch of student teams from around the world come into an environment that we've made that they can then run a pen test on and find vulnerabilities and write reports on. And then I'm also a core red team member for CCDC, which is a competition where we turn that on its head. We give students a secure computer environment and they have to defend it against a group of red teamers. Earlier this year, I also wrote a book called Adversarial Tradecraft in Cybersecurity, Offense versus Defense in Real Time. Some of the lessons from this presentation have been drawn from that book. So if you like this content and the way I present it, please check out that book. You can also find me on Twitter at Injection, and my blog is lockbox.blogspot.com. And down here is just a little primer on the book if you want to see more about it. So first, what is a keylogger? Keyloggers are a very old technique. They were invented in the 1970s in Russia to record terminal users' commands entered into a keyboard. But essentially, a keylogger does just that. It records every key typed into a input device at a computer. This is most often used for offensive purposes or spying, for gathering credentials, such as we can see in this example from Nullbyte at the bottom of the screen. This is the keylogger built into Meterpreter, a very common offensive platform. But there are also like legitimate keyloggers, for example, like kid loggers or the kind of nanny cam things to record what relatives or loved ones may enter into a computer. I'm not condoning these are all very taboo. Keyloggers are used extensively in malware. This is the MITRE attack page on keylogging, T1056 input capture, and it's actually a sub-technique 01. And we can see over 162 different references to keylogging on this page. These are all different kinds of malware across different threat actor groups. They could be geographically different locations. They could have different targets, different verticals, across many different years we see here, and also many different implementations. And then it's also included in many popular frameworks. So we can tell keylogging is an extremely popular technique. It's used in all kinds of offensive frameworks, malware, even red team techniques. And the reason it's so powerful is it gives an unprecedented view into the human side of using a computer system. It's the kind of stuff you can't easily get from collecting technical information from a computer system. A great story, I was using keyloggers once in an offensive operation. We had just compromised a new user and pivoted to their machine, and we dropped our keylogger because we wanted to know specifically what this user was accessing and how they accessed it. But in deploying this keylogger, we saw them opening up their corporate chat solution and start to type to the security team that they thought they'd been compromised. And they actually asked for somebody to come up to their desk and investigate, the potential compromise right then and there. This is information that we wouldn't have gotten if we weren't keylogging what they were actually typing to the security team. So because of that, we were able to remove our implants and back everything out. So that way, when the security team did come and triage the machine, they didn't detect us. So that type of operational intelligence is huge. And you won't get that from traditional tools that just collect artifacts on a computer system. What we're essentially targeting here is the principle of humanity. Essentially, the principle of humanity states that computer systems are designed for human use and for operators to access data and data systems. As a threat actor, we can abuse that by targeting those users figuring out how they use these systems, how they normally access them, and piggybacking on that access or abusing and gaining that access. This is one of several principles that I outline in my book, which I think are core guiding philosophies of red teaming, such as hunting privileged users. Physical access is another one. The principle of economy, the idea that you can only implement so many things on any given side. But the principle of humanity is the key thing I believe we are abusing when we use keyloggers and we start to collect all of this operational intelligence on the user of the machine that we are targeting. So we're going to start to look at some examples here. We're going to start with Windows because I think this is probably the most ubiquitous operating system, and there's many ways to implement keylogging on this operating system. So to start, you can do different kinds of hooking. You can actually hook the functions themselves, such as the keyboard input functions, or you can hook the keyboard, and then you can use API-driven functions like get key state to say every time a key is pressed, get the key state for that specific key. The most popular technique on Windows is get async key state, which is kind of used in a polling manner where you'll loop through a variety of different keys, and then get async key state just returns the state of that key, whether it's pressed up or down or held. And this we'll see is implemented very widely. And then there's also other techniques such as abusing ETW. There's a new ETW technique that allows you to collect key logs. And this is already implemented in some frameworks like Empire. So here's an example of the get async key state implementation. This is a PowerShell example that comes from this Andrea Fortuna blog. And first we can see that it's looping and it sleeps for a certain amount of time in between each loop. The next thing it does is it goes through all of these ASCII key codes, and then it actually calls get async key state with these ASCII key codes. So it's trying to get the different state of every key. One very common thing you'll see on a lot of these keyloggers is they have these virtual key state maps, and then they will do lookups, and this essentially translates this ASCII key code into the human readable key. Is it A, S, D, F, G, or is it a shift, or is it a special character or symbol or a number? That's what those virtual key translations are there for. And you'll see this pretty much in every keylogger. It's sometimes just like a large list of virtual keys. And that's usually what takes up the majority of the space in virtual or in any kind of keylogger, as the actual keylogging is typically very simple, such as a single API call and then a loop. And then finally, most keyloggers will write their keys to a file, or they could store them in a memory buffer and send them off of the system. So when we think about the text, there's a lot of different ways we can approach this. This is called the pyramid of pain. Some people may or may not have heard it, but the idea is that targeting different parts of the operations to write our text will have a different return on value and impact on the attacker. For example, we could just target hash values of specific tools, but that would be very easy to dodge. Say if they recompiled the tool. Alex Levinson and I released a tool at DEF CON, I think it was like DEF CON 26 or something, but we released a tool called GScript, which did just that. It allowed you to very quickly recompile, and it would re-obfuscate the entire binary, changing all kinds of values in code, and obviously changing the hash values and quickly changing the tool. And that just defeats these very weak detections where you're just trying to detect a hash value. You can also have tool-based detections. This would be like if somebody was running that PowerShell script and they had specific command line values, or there was a specific way that a tool did something that was more obvious. You can write those to text, but again, there's so many different ways to implement keylogging that it'd be really easy just to pick up a different tool or change the implementation, but still use the same underlying method. So finally, what we're going to try to look at in this presentation is technique-specific detections on the behavior. These are often called TTPs or tactics, techniques, and procedures. And these are the hardest stuff for an actor to change because they have to change the technique that they're using, which often becomes very difficult um, versus just changing the tool or recompiling the tool. Quick note, I always thought the pyramid of pain was backwards. If this is the hardest thing for the attacker to change, I feel like it should be at the bottom of the pyramid. You should have to change everything above it as well. But that's an aside. So actually looking at some detections on Windows, we can start again with very basic detections. This will apply to all the operating systems, but I'm just going to mention it here. Looking for things like auto execution start points or persistence locations is huge because all of these keyloggers are basically going to start on runtime. You're going to want to run them as soon as the user starts running the machine, or if it's a C2 or an agent, you're going to want to persist it somehow, typically. So those general detections, looking at those locations. And then again, like we said, egress traffic, they're going to have to get the key logs off the system somehow. If they're writing to a file, they'll collect it later with a C2. But if they're doing something a little more fancy with like storing the key logs in a memory buffer, they're going to want to ship them off of the system at some point. So that could be DNS, UDP, TCP. Common ones are FTP and mail, just like sending them away. So look for that, like strange traffic leaving the computer, which could potentially be key logs. A very common implementation for detection on Windows is these EDR platforms will hook get async key state, and then they will monitor this for what program's calling it, how often are they calling it, and how are they calling it. And in doing that, we've seen many large EDR vendors roll out detections for this get async key state. And the problem with that is uh, it can lend itself to a lot of false positives. A lot of legitimate applications also use these APIs. So by increasing your polling window, you can avoid some of these detections by looking a little bit more legitimate. The problem with that is as you increase that polling window, your keylogger can start to get lossy and it'll drop keys that it should be logging, which can lead to problems if it's like a key and a password. Normally, if you have a lossy keylogger, that's okay. You can work around that with just the context of the rest of the keys, but something to consider. And then in this image below, this comes from the most recent MITRE ATT&CK evaluations. Every year now they've been doing these evals with a bunch of defensive products where they will stand up an environment and they run a series of tests with all these different EDR vendors. And their tests are modeled after a specific adversary. In this latest case, it was Fin7. And then they'll run through this series of tests with all these vendors, and then they publish all of the detections and the corresponding techniques. So this was a screenshot I grabbed from the last MITRE ATT&CK evals, again, all public on their site. And this is Bitdefender detecting when a new keyboard hooking event occurred with this defender upgrade.exe. So here we can see them detecting a new hooking of a keyboard event, and then that raised this detection for keylogging or input capture. They called it a different sub technique, but it is still 1056, and they did detect the actual keyboard hooking if you were to look at the details of this, which in my opinion would be technique subtechnique 01. So then moving on to the Linux offense, this is where things get very tricky. If you've ever actually tried keylogging on a Linux system in production or a remote Linux system, you've probably tried your typical keyloggers, which you can find on GitHub, which are actually device keyloggers for Linux. And you've probably been disappointed because you've noticed that you haven't collected any keys on your remote system. This is actually the problem that led me into researching this whole space a bit more because I wanted to understand that. So to start, there's several techniques that exist on Linux. The one that you'll see a lot of implementations on GitHub is device keylogging. And what this will do is it'll find your device file for your keyboard, and then it'll read from this file just like you were reading from the keyboard, and it'll then log it to a file. This falls apart when you look at remote machines because they don't have the physical keyboard device. They use pseudo terminals. So we'll get to that. Another very popular technique is GUI polling. Similar to Windows, if you're using KDE or GNOME, there's usually an API GUI like xQuery key map, which will then tell you all of the key presses that are being entered into that GUI system. This can be useful if it's a remote system with a GUI, like a jump box that are people using. Unfortunately, in my experience, very rarely do these Linux jump boxes ever have GUIs. It's usually just a bastion with SSH access that people then pivot through. So that's where things get tricky, because if we're talking about that situation, these previous keylogging techniques will not work for. In that final situation, the most common situation where you have a Linux server that people remote to, let's say in production, and then they do their operations, you need to use shell wrappers. And there's two really good techniques that you can use here. One is actually editing this authorized keys file, and then you can place a command before the specific key, and that command will get ran. And we'll look at that. And then the other is just editing etc password and replacing the user's default shell with a logging shell wrapper or keylogger. So here we can see two examples of those techniques. This is the authorized keys file for some user in SSH. And here's what it would normally look like. And here's where you can add a command in front of that authorized keys file that'll run whenever that user authorizes. And then if you go to jms1.net, this is a very old technique. And then he has his log session script there. And that's just a bash script that sets up some basic logging, opens up a file for the log, and then we'll just log everything to that file, I think using T before actually executing the commands themselves. So very basic stuff. This is a very old technique. If you visit his website, you'll see that, and it's an old script, but it still works, and it works really well. Another very old technique is just replacing the user shell. So you can edit etc password, and then you can replace the line with their default shell with a tool like this called root.sh. The original root.sh was written over 10 years ago in C. This is a rewrite in Go. Still the same thing, very effective and very small. If you look at the actual code, again, just sets up a new file, sets up some basic logging, and then just logs the command next command. So very old techniques, but still very useful and kind of that edge case for remote Linux systems that most operators might not know about. Detecting these techniques is also very old and simple. A very popular Linux security technique for many years has been file integrity monitoring, because everything on Linux is a file. And here we can see AID, which is a open source free file integrity monitoring solution for Linux, finding etc password being edited to replace the user's shells. Both etc passwords and the SSH authorized keys are very key files you should be monitoring anyway with file integrity monitoring. For example, SSH authorized keys will allow a user to persistently access the box as that user. So that's a big persistence location to just be checking for new access or to see that modified. So you'll definitely want to, if you implement these solutions and these defenses, you'll definitely want those files in your file integrity monitoring. Keylogging aside, they're important files to monitor. Moving on to macOS. First, a lot of the same techniques exist. For example, because macOS is a Unix system, all of those same Linux techniques carry right over. So you'll get the shell replacements. You can also edit the authorized keys file if you have remote SSH set up on your Mac. However, the most popular technique and example on Mac is creating an event tab for the key down event. We can see this here. This is pretty simple. We can see this example in C by Casey Scarborough. But this is a very widely shared and common example. Basically, you start by creating an event mask for your key down events or your key change. And then you create the event tap on both the event mask, which is the key down, and then a callback. The callback function is what will get executed every time you have your key down. And it's just a very simple function where you write that key down event to your file or keep it in your memory buffer for later exfiltration. So this is a very common and simple implementation where you see this event tab created, and then they just write to a file. The detection here is also pretty well explored. Um, Patrick Wardle of Objective-C makes a lot of really cool macOS tools. And here's one that he made called Rekey, which lets you monitor for event taps on macOS. So, and again, like Patrick puts a lot of thought into his detection tools. One of the big problems with these keylogger detection techniques is just simple false positives, because legitimate programs will use these. So not only will he show you all this stuff, but then his version also includes filters, so that way you can like whitelist all of these macOS event taps that are doing the same thing. So you'll only see like strange, unknown event taps, which is very helpful for bubbling up threats, especially for users. Like if you just want to give this to all your users and give them a known configuration, that's a pretty helpful way to do that. Finally, I felt like this presentation would be remiss without mentioning physical keyloggers. Physical keyloggers are a good way to add these techniques to basically any machine that has HID input or keyboard input. The caveat obviously being here that you have to have physical access to the device. So just a few different cool solutions on the left here. This is just like a USB man in the middle type solution. You just plug the keyboard into this and then this into the computer. The neat part about some of these solutions are, they have a bunch of internal storage to leave these keys on, but then some of them also support wireless or Bluetooth exfiltration of the keys. So if you're just near the keylogger, you can dump the keys to a phone or a laptop. And then on the other side, we see the OMG cable. MG has been making these awesome cables with embedded devices in the cables. And this one, actually, he has one that has keylogging features and support. This is great for those Apple Magic keyboards where you have the wire that connects the computer to the keyboard. You can have everything just sit in that cable. It's very powerful. So some final takeaways from this whole thing. We saw how powerful keylogging is. The technique is very old. It's used in a ton of malware because it gets that human operational intelligence that is hard to get another way. We saw how keylogging can be implemented across many common operating systems and even physically, if it's an operating system that just has like physical HID inputs. So it's very easy to implement. And most importantly, we saw how keylogging itself is a specific detectable technique in an attacker's kill chain. This is important because not only can you detect around the keylogger, like the persistence or the auto start execution points or the exfiltration, but specifically you can detect the keylogging technique now in the kill chains, which is just another touch point where you can catch attackers. So some more thoughts on keyloggers down here. I have a blog post where I expand on this. And then also, a lot of the inspiration from this research is in that book, Adversarial Tradecraft on Cybersecurity. So if you like some of these notes, you'll find a lot more of that stuff in the book. And then also the presentation matches the book where it's the back and forth. We look at an offensive technique and then how do you detect it? How can you turn it against the attackers, etc. So thank you very much. This has been Keylogging Across the Operating Systems, and I have been your host, Dan Borges.